Could you hear me in room, Ella Marie? I could come right back.
Anything, people online? Oh, okay. Well, then we were not left with the right setting. So sorry for that, folks online. I think we just got it now. All right, Kathy, go ahead.
Thank you. So to that end, we developed a survey and we asked a couple of questions that we thought would influence the probability of choice. We also asked sociodemographic questions. So one question we ask is about knowledge. What do consumers know about poultry meat? And we ask, have you heard before of meat production without raising and slaughtering of animals? We also ask food technology neophobia. So with this scale, we measure traits of food technology neophobia. And we ask, to what extent do you agree or disagree with statements such as new foods are not healthier than traditional foods, or new food technologies decrease the natural quality of food. We also ask trust questions, and we want to know how trustworthy do consumers think people and institutions are. And we include different institutions. We include the government, third-party certification bodies, health professional, expert scientists. We also ask social media, family and friends, and how much they trust in these sources. We also add the religiosity scale, and this is a 5-item measure of religious involvement. And the question that we ask is, to what extent the following statements are true or not true? And some of the statements that we include is, my religious beliefs are what really lie behind my whole approach to life. And I tried hard to carry my religion over into all other dealings in life. So we also have a choice experiment where we include 3 attributes: product, price, and the organic label. The products that we include are hamburgers, chicken nuggets, and hot dogs. The prices are those 4 price points you see there, and the organic will be the organic label or no label. We have 4 different treatments in our study: culture meat, cellular meat, lab-grown meat, and cultivated meat. And the way it works is that a person that is taking the survey will be assigned to one of the treatments. So that person will see, if that person is assigned to culture meat, you will see culture meat all along the survey. So they will only be assigned to culture meat. And we explain to them what culture meat means. Participants will make 8 different choices that look like this. So this person in this example, person is assigned to cultivated meat. So we'll see cultivated meat, conventional meat, and plant-based meat. And you see the prices and the organic label. This is randomly assigned, so prices will vary, and they won't see the same scenario in their tasks. And after each of these pictures, we ask them, imagine you're hungry and would like to purchase a burger. Would you choose option 1, option 2, option 3, or none of these? And they make their choices there. So the data collection process start with phase 1, where we pre-test in person here in the Boston area. We ask 55 participants to give us feedback in the format, the questions, and like everything about the survey. And with that feedback, we came to phase number 2, which we have the survey and we send it using Qualtrics. We send it to a representative sample of the US. It's a survey that is 10 to 15 minutes long. We got the data set last week and we had 814 participants. In phase 3, is a German study. Is going to be the same survey, but in German. And you will have some modifications to country-specific questions. These are preliminary results. So people that were assigned to the cultivated meat, they were 27% more likely to choose cultivated meat. For culture meat, 28% were more likely to choose culture meat. People that were assigned to lab-grown were only 20% likely to choose lab-grown meat, and cellular meat, 26%. And this is like lab-grown is the term that was less likely to be chosen because it's not too appealing. Some preliminary results of the logistic model regression, or the logistic regression, is that from these variables, the only one that is statistically significant and positively influence participants' probability of choice is the organic label. As participants score higher on the neophobia scale or the religiosity scale, they were less likely to choose culture meat, and we were expecting this. As participants in our study were older and female, they were less likely to choose culture meat. And as expected, as price increases, they were less likely to choose culture meat. This question we ask also is, imagine there is a policy that would only allow that products that come from poultry that has been born, raised, and harvested traditionally can be labeled as chicken. Would you support or oppose this policy? And 78% of them said that they will support, so no chicken on the product that is cultured. And as conclusions, industry has settled a good term for the purposes, but not necessarily the best. Stakeholders' concerns and opinions need to be heard of consumers and everyone involved. The debate over nomenclature is a valid one with high stakes, especially now that the products will be in the market soon. Labels and names affect consumer acceptance of products. And longer-term public acceptance will depend on the products that are going to be on the market and will be shaped with the regulatory debate. And public policy and investment should be based on long-term needs, focusing on sustainable solutions to society and to the environment. My presentation. Thank you. We ask questions here or at the end?
Questions here or?
what extent, would this kind of survey where you're asking people what they would choose, how does that predict actual consumer behavior, say when they're purchasing products?
Well, there are many studies saying that it could predict their decision and their probability of choice. That's the best we can do right now with a hypothetical product that we cannot offer to them, but we can ask and see what is that probability. But that's as much as we can do right now with a hypothetical product.
But it's a good question. What would you do and what they do?
Yeah,
No, that's okay. I was just kidding.
Okay. So the policy results are quite striking. Reading this as a survey respondent, I'm wondering if this was interpreted as a cell cultured product would just be labeled chicken the exact same as something in the grocery store. So it's like I, as an individual, I'm on the Cell Ag project. I wouldn't want that. I would want to be able to tell the difference. But if it's chicken versus cell cultured chicken or cultivated chicken, I think there's a couple things, there may be a couple things tangled up in here that like, it's very clear that people don't want it labeled as the same thing, but what would this response look like? Do you have thoughts on what this response might look like if it was, there's a descriptor before chicken, because industries in many cases just does even want them to be able to use the word chicken at all, right? Like lab grown product analog, something, right? That's what they would like. So do you have a sense of how you think this might differ as if chicken is part of the name versus it's just chicken? You know what I'm saying?
Yeah. Good question. So I think probably we would be like, it was a good idea to add a question of like the cultured chicken, or, to have that idea different to what we have here that is like the chicken one. And I guess we already collect the data, but yeah. So yeah, this is more towards what you were mentioning at the end of like, yeah, they don't want to call it chicken at all. So just put the like lab grown something, just put it there. And we just wanted to know that, but yeah, it would have been good in this.
That came in over Zoom was just, can you say more about how pricing impacted choices in the experiment?
How much?
Yeah.
Yeah, so that's the main, like one of the main drivers of probability of choice is price, and is the one that we look at very closely because as price goes up, we know that the probability of choice is going to go down, and it impacted a lot. Is one of the main predictors.
Great. Thank you so much, Kathy. I think we should move on since we did lose a few minutes to the technical issues, but please everyone join me in thanking Kathy for her talk. And it's great to have an opportunity to get some hot off the press results. So. Right. So our next presenter is, if you want to, here, let me, I'll fiddle with you. No. Come on up, Danielle. I was just going to ask if you invite you, if you wanted to, which one's yours here? This is the. Just want to make sure you're all set. Okay, so those of you who have been around Friedman for a while might know Danielle, even though she is she's just started her position as a postdoctoral scholar in the last 2 months. She's double jumbo, did her master's and PhD here at the Friedman School, and she is now the inaugural RRSP collaborative postdoctoral scholar at Tufts, working across 2 of the different research collaboratives that the Provost's office helped set up in the last few years, working with TGOR, the Tufts Institute for Global Obesity Research, as well as the Equity in Health, Wealth, and Civic Engagement across the Friedman School and the Elliott Pearson School for Child Development. Danielle, if there's anything else you'd like to tell people about yourself before you begin, feel free. Otherwise, please dive in.
Thank you. All right, so thank you, everybody. It's great to be here today. I think Sean gave me a great introduction, so I'll just jump right into it for the sake of time. Today, I'll present some results from an ongoing study where we're exploring the associations between contested racial and ethnic identity and exposure to interpersonal discrimination on adult obesity risk. So this work is guided by mentors and collaborators, Drs. Jayanthi Mistry, Chris Economos, and Adolfo Cuevas. And you can see that they each, including myself, bring a multidisciplinary skill set of expertise to really focus on health equity in this work. Almost half of all adults in the US have obesity, and there are notable racial and ethnic disparities, placing Black, Hispanic, and Latino populations at a much greater risk than their white counterparts. So to prevent these rising inequities, public health policy and interventions must be developed with equity at the forefront. However, to do this requires novel understandings of the etiology of population-level obesity risk. So measuring race in tandem with other individual social indicators is critical to unpack the influence of racism on health and obesity disparities, as shown in this framework by leaders in the field, David Williams and Selena Mohammed. And here in this framework, ethnicity is grouped as a component of race, since ethnicity in the US is racialized. Nonetheless, the operationalization of racial identity constructs requires improvement, nuance, and specificity. So to date, our understanding of obesity and health disparities has relied primarily on self-reported, self-identified data. However, as shown in this framework, racialization is complex with direct effects on health. Racialization as a construct reflects the compounding of individual identities, intra-group dynamics, and perceptions by society based on their ascribed racial and ethnic identities. 2 ways that people in the US are racialized are through, as I stated, self-identified race, but also their socially assigned race. Socially assigned race is the imposed categorization of an individual by others in society. And contested identity refers to an individual whose self-identified and socially perceived race are mismatched. Racialized experiences, including having a contested identity, can increase exposure to discrimination. A notable amount of literature has linked interpersonal discrimination experiences to elevated stress, poor mental health, excess adiposity, and weight gain, but the pathways through which it influences obesity risk remain unclear. The research on socially assigned race and health has been led by Dr. Kamara Jones, whose landmark 2008 study found that socially assigned individuals who were socially assigned as white, regardless of their self-identified race, had better overall health outcomes. And a 2022 study in preventative medicine examined contested racial identity among women and their infants and found that contested identity, again, regardless of self-identified race ethnicity, was common, and it was associated with significantly poorer healthcare services and greater risk of women with low birth weight babies. And finally, a scoping review from 2020 determined that socially assigned race and contested racial identity have not yet been examined in relation to weight status or obesity. So therefore, this study sought to address the following gaps in knowledge: a better understanding of the relationship overall between a contested racial ethnic identity and BMI, more insight on the role of interpersonal discrimination on weight outcomes, and understanding better how contested racial identity and discrimination influence obesity risk. Specifically, the overall aim of this study was to examine the association between a contested racial ethnic identity and adult BMI in a national cohort of US adults. We hypothesized that reporting a contested identity will be positively associated with BMI. We next explored whether discrimination exposure could influence the association between a contested identity and BMI. So data for the study comes from the Equity in America survey, which was designed by the Equity Priority Research Cluster that Sean mentioned, co-led by doctors Tom Stopka, Jayanthi Mistry, Jen Allen, and Peter Levine. So then the Tufts group contracted Ipsos, which is a social marketing research firm, to conduct the online study nationally. The self-reported race ethnicity data come from the baseline consumer survey that was administered by Ipsos to ensure national representativeness of the panel, based aggregated by race, and then by ethnicity, and then the racial groups listed on the screen. And socially perceived race and everyday discrimination was measured in the survey using validated items that were selected by the Tufts researchers. So the methods that I used in the study were a series of unadjusted and adjusted regression models with continuous BMI as the dependent variable to examine whether contested racial ethnic identity influenced adults' weight status. I first tested the associations between contested racial identity and BMI, and then with a stepwise approach added the mean everyday discrimination score into the model to determine whether it helps to explain the influence of contested identity on weight. And in the adjusted models, we controlled for the participant's self-identified minority status, meaning whether minoritized status, so whether they socially, now I'm confusing myself. Sorry. In the adjusted models, we assessed whether or not an individual self-reported belonging to either Black, African American, Hispanic, Latino, Asian, NHPI, or American Indian alone or in combination. So individuals who were multiracial would be included as a non-white group, obviously. So then we also controlled for age, gender, and household income. Just a little bit details on the independent variables and how they were constructed. So this slide shows how contested racial ethnic identity was created, and this was modeled after that 2022 AJPM study. Socially assigned race was assessed with a select all that apply question by asking, how do other people usually classify you in this country? Self-identified race in the baseline survey was assessed with the standard procedures that we're pretty familiar with by first asking ethnicity and then asking to select all that apply from 6 racial categories. So then I developed a set of binary variables indicating disagreement for each of the 7 racial ethnic responses, and then an overall binary indicator for contested identity if there was disagreement for any of these variables. So for instance, an individual who self-identified as white and Hispanic Latino, but is socially perceived as only Hispanic Latino would be considered to have been reporting a contested identity. Oops. And then we also did include socially assigned white in the model based on whether or not an individual responded affirmatively based on whether or not an individual reported being only socially perceived as white. And then finally, interpersonal discrimination score was assessed with a validated 5-item survey. The questions are shown on the left. Respondents were asked to answer along a 6-point scale shown on the right, and these responses were averaged to create a mean score so that higher scores represent greater discrimination exposure. Moving along to results. Table 1 presents the descriptive statistics for the 1,700 participants that were included in the study. Continuous variables are presented as means and standard deviations, and categorical variables are shown as frequencies and percentages. The values in columns 2 and 3 are row total percentages, so they indicate the share of each demographic group with or without a contested identity. We find that 24% of respondents reported a contested race or ethnicity. The overall discrimination score in the sample was 1.95, and the mean age was 52. Among those who reported a contested identity, the discrimination score was higher and their average age was younger than those who did not report any contested identity. Over half the sample had an income above 75,000 a year. So it was overall appeared to be economically advantaged. However, individuals in the middle income category had a higher prevalence of contested identity than others. The sample was diverse as well. 23% of the respondents were non-Hispanic Black, 31% were non-Hispanic White, and 22% were Hispanic Latino of any race. 81% of Hispanic Latino participants and all who self-identified as exclusively other reported a contested identity, which was higher than the other groups. And 64% of the sample had a BMI that fell within the overweight or obesity categories. Yet those in the healthy BMI group had the lowest prevalence of contested identity. Table 2 presents the results of the multivariate regression models examining influences on BMI. Column 1 shows the unadjusted coefficients without discrimination in the model. We found that having a contested racial identity was associated with a 1.15 point higher BMI. Adjusting for the covariates in column 2 slightly attenuates the magnitude of contested identity on BMI score, but the coefficient remains positive and significant. Adding mean discrimination score to the model shown in column 3, it appears that discrimination is associated with it's still associated with a higher BMI of about 0.76. Yet the relationship between contested identity and BMI remains strong and significant. And then finally, adjusting for covariates, including discrimination in the model, the positive association of contested identity on BMI remains strong, as does discrimination, suggesting that both constructs are linked to an increased BMI, but could operate independently. So in conclusion, we found that contested racial identity was a common manifestation of racialization reported by 24% of the sample. And as well, we found that contested identity was significantly associated with an increase in BMI in the multivariate regression models. The mean BMI was higher among those who reported greater exposure to discrimination, but we did not find that discrimination exposure influenced the relationship between contested identity and BMI. So to unpack the impact of racism on within and between group obesity disparities, additional research is needed. This could begin by harmonizing the survey items used to assess self-reported and socially assigned race ethnicity, improving statistical techniques to account for multiracial ethnic populations, routinizing the collection of nuanced indicators of racialization, such as socially assigned and contested identity, replicating and implementing more rigorous analytical methods, since these, I would like to underscore, are very early findings. Socially perceived race and contested identity, to my knowledge, are lacking in the obesity literature, but it seems that there is some sort of a relationship there. And finally, qualitative research could really help to explain some of these underlying relationships. For example, do social resources such as inter and intragroup cohesion protect against excess weight gain? So I would just like to thank the full team of collaborators, and we can now open it up to questions.
Thank you so much, Danielle. Questions from the audience or over Zoom?
I have a minor questions. Honestly, I wouldn't ask if your focus is not the race, and I don't think it will affect the result. But in one slide, you have a race, you call it Asian. So, the Asian is quite complex. We have East, Southeast, South Asian, and West Asian. They are all different. So I'm wondering if you can collapse that group into different smaller group. It have anything to do with your research?
I do think that Asian group, we had very, very few Native Hawaiian Pacific Islander respondents. And so we had combined them with Asians in one of the models, but I think what we need to do, and actually the government is currently doing this, is expanding the groups to really disentangle that population. Because I think that they are overly simplistic.
There's a question here from online from Alexandra. Can you talk more about people with contested race, but who are socially assigned as white? Did you?
Yeah, that's definitely should be an additional step in this work. What we did was very high level, just to see how that disagreement between how one identifies versus their perceptions in society, how that might influence the weight outcomes. But previous research finds that social assignment as white does confer benefits on health. Whether or not that translates to obesity risk or weight is yet to be.
Of course.
Thank you, Danielle. Curious about within family. I know this is really a new area of research, but children, parents within family having different perceptions of how they're socially identified and whether or not there's any new literature showing that that could have an impact on health.
Yes, thank you, Chris. Well, I do think that family contexts, dynamics, culture, all of these things influence how individuals are racialized in society. Well, whether it's self or social, there's growing literature on the differences in self perceptions of one's race or ethnicity based on immigrant status, especially within Afro-Latino populations. But I think that this type of data set where you have intergenerational participants like parents and children could be really interesting.
There's a comment or a question or suggestion on Zoom about adding immigrant identity component in future research, but was that something you have some data on currently, or?
So that is a great point. And I just found out, so the way this works, there are in the baseline survey, nativity, so country of origin, country of birth was collected, and Tufts very, very recently purchased that variable that would come from the baseline survey. So I think in future iterations and any sort of publication, we would definitely want to examine that and consider that as well.
And the last question.
It just seems to me that one of the things that's really coming out of this and the discussion is this issue of what do we mean when we assign a racial category? We know that, more and more people are saying check all that apply or something like that. But I see a kind of an area to go into that looks at, is everybody in the household, do they consider themselves the same? That whole, I don't know how you get the socially assigned. The categories themselves aren't nuanced enough. So somehow that I'd love to see that pursued.
Yeah, that's definitely a great point. I agree that the categories are not nuanced enough, but that's sort of what at a high level this is trying to get at, is by saying, well, it's not just a binary check a box. It's also influenced by how individuals view you, how you view yourself, and thinking of how to include this regularly in health research going forward.
Thanks so much, Danielle. And with some of these questions too, I'm reminded of some of the conversations that I know were in the seminar that B leads and that you were part of, about these tensions between having close-ended questions that you can apply to a lot of people, having open-ended questions, and then having a coding problem where then that forces the researcher to then assign things to people to figure out what they meant. And is that, there's not any one easy solution to a lot of these things. So, but it was great to see where this has gone. Thank you so much. We look forward to hearing more. All right, I'm going to try and fail to do a nice job of both switching slides while trying to introduce our next speaker. So maybe I will just get the slides up first. There we go. All righty, then I can do the introduction. Our last speaker today is Dr. Lu Wang. Dr. Wang is a postdoctoral fellow at the Friedman School, whose research interests include modeling the health and economic impact, as well as cost effectiveness of nutrition-related policies on reducing non-communicable diseases, and understanding the role of diet and health outcomes in epidemiological studies. She completed her PhD at Erasmus University Medical Center, but she's been here at the Friedman School for a while and has been able to work across a few different teams and with different researchers here. Lu, look forward to hearing your presentation.
For the introduction, and I'm happy to be here to present my research, and let's get started. So I'm going to talk about the association between ultra-processed food consumption with colorectal cancer risk among men and women in 3 large prospective US cohort. Colorectal cancer is the third most commonly diagnosed cancer and the second leading cause of cancer in the US. And diet is an important modifiable risk factor for colorectal cancer. For example, there is probable or convincing evidence that consumption of processed meat, red meat, and increased body fat obesity increase the risk of colorectal cancer. While foods high in fiber, diet or whole grains or dairy products can decrease the risk of colorectal cancer. And our previous work suggests that ultra-processed food is contributing to an increased proportion of daily calorie consumed by U.S. children and adolescents during the past 20 years. And similar trends have been found among adults, and now ultra-processed food contribute to about 57% of total daily calorie consumed by American adults. So, and ultra-processed food is industrial formulations made mostly from substances that is extracted from foods rather than whole foods, and such as fats, starches, added sugars, with the addition of some non-culinary ingredients or additives such as artificial flavors, colors, and sweeteners and emulsifiers. So examples of ultra-processed food include sugar-sweetened beverages, frozen meals, hot dogs, packaged cookies, cakes, and salty snacks. While these foods have played an important role in food security because they are microbiologically safe and provides very highly accessible because they are relatively inexpensive and provides the convenience of ready to eat or ready to eat. And several characteristics of the ultra-processed food may cause health concerns and may link to cancer risks. For example, ultra-processed food can facilitate overeating because they are highly palatable and therefore may contribute to increased risk of weight gain or obesity, which is an established risk factor for colorectal cancer. And ultra-processed food are also nutritionally unbalanced. They are low in nutrients and are beneficial for the prevention of colorectal cancer, such as low fiber, calcium, and vitamin D. And also some food additives that are common ingredients of ultra-processed foods, such as dietary emulsifiers and artificial sweeteners may promote inflammatory potentials of gut microbiota in the intestine and may therefore promote carcinogenesis. And further, in some chemical contaminants that is formed during processing, such as acrylamide formed during heat processing, or some chemicals that is migrated from packaging of ultra-processed food may come with some carcinogenesis potentials. But whether ultra-processed food contribute to linked to colorectal cancer risks have not been established. So previous evidence are very scarce, and these only 2 studies have assessed the association, and they are limited by the study design or low sample sizes. So this study aim to evaluate the association between ultra-processed food consumption and the risk of colorectal cancer among men and women who participate in 3 large prospective cohorts. We also look at the association by anatomic subsets. Since colorectal cancer is also considered a heterogeneous disease with potentially distinct etiology for tumors developed at different anatomical sites. And we also look at the association of subgroups of ultra-processed food with colorectal cancer risk. So we use the data of men and women participating in 3 large prospective cohorts. So including the nurse health study, which followed from 1986 to 2014, the health professional follow-up study from 1986 to 2014, and the nurse health study 2 followed from 1991 to 2015. And so we excluded those without a valid baseline dietary intake measurements and those with previously cancer diagnosis. Dietary intakes were assessed by validated food frequency questionnaires with about 130 food items that is administered every 4 years. So all the food items collected in the food frequency questionnaire are categorized into 4 groups according to levels of processing using the NOVA classification. And this diagram shows the process of food categorization. So basically 3 researchers worked independently to assign each food item to a NOVA group. And in the case of disagreements in the classification, discussions and the additional resources are used to guide the final categorization. So colorectal cancer diagnoses are self-reported in biannual follow-up questionnaires and confirmed by study physicians. And covariates including demographics, lifestyles, endoscopy, medications, and supermetrics are assessed every 2 or 4 years. So we use the Waring-Cox proportional hazard model to examine the associations which accounted for the repeated measurement of dietary intakes and the covariates. And all the models adjusted for potential confounding factors, including age, calendar year, race, family history, endoscopy use, physical activity, smoking, alcohol intake, and aspirin use, menopausal status, and postmenopausal hormone use. And this table shows the baseline characteristics of the study participants by quintiles of ultra-processed food intake. We can see that among both men and women, compared to those in the lowest quintile of ultra-processed food intake, participants in the highest quintile have higher BMI and were more likely to be current smokers or smoke more pack years and have lower consumption of alcohol and less physical active, and they are more likely to use aspirin regularly. So after multivariable adjustment, so we found that men who consumed ultra-processed food in the highest quintile had 29% increased risk of developing colorectal cancer than those in the lowest quintile. However, no significant association was found among women. And we also, when looking at the risk of anatomic subsets of colorectal cancer separately, high ultra-processed food consumption was associated with increased risk of distal colon cancer, with with 72% increased risk in the highest quintile compared to the lowest quintile, but no association was found for proximal colon or rectum cancer, and we found no association among women. So, and in additional models and further adjusted for BMI, Western dietary patterns, or alternative health eating index, or some key food groups or nutrients and are associated with colorectal cancer risk, the results are not materially altered. And in sensitivity analysis, that's using percentage of energy from ultra-processed food as exposure, or using alternative classification of uncertain items in classification, also confirmed our finding. So since ultra-processed food contain a variety of foods which may have different health implications, we further explored how subgroups of ultra-processed food link to colorectal cancer. Our results suggest that higher consumption of meat, poultry, or seafood-based ready-to-eat products or sugar-sweetened beverages were associated with increased risk of colorectal cancer among men. And ready-to-eat or heat mixed dishes was associated with increased risk among women. And yogurt or dairy-based dessert was negatively associated with risk of colorectal cancer among women. So in summary, in this study, of 3 large prospective cohorts, we found that increased consumption of ultra-processed food those men with increased consumption of ultra-processed food have increased risk of colorectal cancer, and particularly distal colon cancer. The association remains significant after further adjusting for BMI or indicators of nutritional quality of the diet, and which suggesting the potential role of factors beyond dietary quality of ultra-processed food that may impact the risk of colorectal cancer. And this finding is consistent with a recent review of 37 cohort studies, which shows that the association between ultra-processed food and multiple adverse health outcomes independent of dietary quality. We found there are no overall associations of there's no association of overall ultra-processed food consumption with colorectal cancer among women. We do find subgroups of ultra-processed food, especially ready-to-eat or heat mixed dishes increase to colorectal cancer. And it is possible that ultra-processed dairy foods have protective impact, so counteract the potential harmful effect of other ultra-processed food. And this could also be a chance finding or due to uncontrolled confounding factors that we are not able to control for. And indeed, we found ultra-processed food consumption is associated with the increased risk of colorectal polyps, which is a precursor of colorectal cancer in both men and women. While our studies provide the important evidence for the potential harm of ultra-processed food, more research is still needed to confirm our observation. And like most previous studies, food frequency questionnaire is used to assess your dietary intake of ultra-processed food, which only include a limited number of predefined food items. So future validation studies are needed to understand the validity of the existing dietary assessment tools in assessing ultra-processed food intake, and future tools shall incorporate the level of processing as an additional dimension. And also experimental studies are needed to further elucidate the biological mechanisms and aligning the association of ultra-processed food with health outcomes. And also studies are needed to test the different public health approaches to reduce consumption of ultra-processed foods. Yeah, that's all my presentation. Thank you.
Thanks so much. Questions for Lou from the floor?
For an interesting presentation. Do you think that when your study is replicated in other cohorts or the same cohorts, that there will still be this gender difference in the association between ultra-processed foods and colorectal cancer?
Yeah, I think it may. First, I want to state that the gender differences is also observed in many studies, like obesity and many dietary factors have stronger association with colorectal among men than women. Yeah.
Men and not women, you said.
Men and not women.
Yeah, among men than women. Yeah.
Yeah. So that's actually very helpful to know. Great. Thank you.
Other questions for Lou?
I have a question on the, so you have one slide show the sugar sweetened beverage and the meat consumption is a component associated with colorectal cancer in men. I'm just curious how much of the proportion of the association between those ultra processed food can be explained by these two components? Are they the major driver, or they're just a small proportion variation can be explained by these two components?
Yeah, we did not look into the association after excluding the sugar sweetened beverage or.
Yeah, in the model, if you adjust for the sugar sweetened beverage, is the model still significant?
Yeah, in the model, we adjusted overall dietary quality.
No, I mean only sugar sweetened beverage in the model.
You mean the association of sugar sweetened beverage with colorectal cancer?
Yeah. In the ultra processed food with colorectal cancer, if you adjust for the sugar sweetened beverage at one covariance, is the model still significant or not significant?
I'll look at this
Okay.
specifically. Yeah, interesting to.
Just curious, do you have one correlation matrix and show which food components are highly correlated with the ultra processed food?
Yeah, we do have a descriptive analysis. Yeah.
Thank you so much. I think we do need to cut off questioning here because we did lose a few minutes because of the technical difficulties, but thanks to the speakers for staying on time. I did want to mention that Lou's study got quite a bit of attention in the press at the end of the summer. And so there was a lot of interesting discussion there and also some rapid response commentaries in the British Medical Journal, right? So this study has already gotten quite a bit of attention. So congrats on all that. Thanks to all our speakers today. And thanks as always to Lisa Cho and Ellen Marie Bransfeld for all the work that they do, keeping the seminar speakers going, and to Jean Talma for coordinating as well. So see you all later. Take care.